Good morning, seventh graders. I hope that we're having a great start to our week and a great day so far. Our video for this lesson is actually going to be still talking about sort of like constant proportionality, scale factor, scale, rate, ratio, all of those words that we can still tie together and are still the same. Today we are going to be talking about computing actual lengths from our scale drawings. Okay? So without further ado, let's get to our
Seventh
video.
grade. Today, we're going to be talking about computing actual lengths from scale drawings. So we're going to want to keep in mind our previous ideas of scale factor, constant proportionality, ratio, rates, everything like that are important to think about. Okay, and we might even want to use our constant proportionality idea in order to help us write an equation using that rate. So let's start with our first example. Vincent proposes an idea to the student government to install a basketball hoop along with a court marked with all the shooting lines and boundary lines at his school for students to use at recess. He presents a plan to install a half-court design as shown below. After checking with the school administration, he is told that he will be approved if it fits on the empty lot that measures 25 feet by 75 feet on the school property. Will the lot be big enough for the court as he had planned? And I can see here in my scale drawing, 1 inch on the drawing corresponds to 15 actual feet in length. So I know here that scale drawing length, which I'm going to say this is my 1 inch, is the same thing as 15 feet. Now I want to use these dimensions that he's put forth, and I want to use my constant proportionality to help figure out what their dimensions actually will be. So I can do 2 inches and 1 2/3, which is the same thing as 5/3. And all I have to do is I need to multiply 2 times 15, which gives me 30 feet, and then 5/3 times 15, and that will ultimately give me 25 feet. So now I have to go back to my question, which I'm going to highlight one more time for us. Will the lot be big enough for the court he planned, and it measures 25 feet by 75 feet on the school property? So I can see that this is 25 feet by 30 feet. So yes, it will fit. Just it'll be very, very close. Okay, let's try another example. The diagram shown represents a garden. The scale is 1 centimeter for every 20 meters. Each square in the drawing measures 1 centimeter by 1 centimeter. Find the actual length and width of the garden based on the given drawing. So there's something that I want to really point out here. They're using the word scale in this case. We're not we're used to seeing things as like scale factor or ratio or rate or anything like that. And I want us to determine that this isn't called a scale factor because the scale factor in a scale drawing is always a scalar between distances measured in the same units. In this case, we're working with different units, which is why this is called a scale, but we can still use it the same way as we have been before. So, let's do this. So I know that 1 centimeter in my drawing is 20 meters. Put our units on there, why not? So now I need to figure out this length right here. My, length is 8 centimeters. And this length, or this width right here, is 4 centimeters. So now all I have to do, I just have to fill in the rest of my table. So I can do 8 times 20, which gives me 160 meters, and 20 times 4, which gives me 80 meters. And that's what the actual length and width of the guard would be based upon the given drawing. And that's how I use a scale in order to help figure out these missing pieces. One last question. A graphic designer is creating an advertisement for a tablet. She needs to enlarge the picture here so that 1/4 inches on the scale picture corresponds to 1 inch on the actual advertisement. What will be the length and width of the tablet on the advertisement? Now, before us trying to figure out what our scale or constant proportionality or ratio or rate, remember all of those are the same thing. Before that, figuring that out was pretty easy. But now it's a little more challenging. So I want to figure that out. So I'm going to do y over x again. And that's going to give me 1 over 1/4, which actually comes out to be 4. So I know that my rate is 4. So now I just take these lengths and widths that they give me in the drawing, and I need to throw it into the table. So I have 1 1/4 inches and 1 1/8 inches. And all I have to do is multiply those by 4. So 1 1/4 is the same thing as 5/4 times 4, which gives me 5 inches. And then 1 1/8 is 9/8 times 4, which actually gives me 9/2, or 4 1/2. So those are all the examples that I had planned for today. Again, these are just examples of us being able to take a situation in the real world, figure out what our scale factor or scale is, and use that to figure out what actual lengths of our actual objects should be based off of a scale drawing. So if you have any other questions, feel free to leave a comment in the comment section below. Feel free to like and subscribe. If you have any other questions, feel free to message me on Schoology. But until next time, I hope that you all have a great day.